So a lot of this we already discussed on the previous page. The first one was the probability that event 1 occurred. Event 1 was the number of even numbers. There were 3 even numbers out of the 6 sides of the die. That gave us a probability of 1/2. If you remember what event 2 was the number of pips being greater than 4. The number of pips being greater than 4 was the sides 5 and 6. So that was 2 of the 6 sides, which simplified to 1/3. You go on to the next event. It was the probability that the number on the die was less than 20. We determined that all 6 of the 6 sides of the die were less than 20, meaning it had a probability of 1 or it was guaranteed to happen. And then the last one was the probability that they were greater than 15. We said 0 of the 6 sides are greater than 15, which gave us a probability of 0, meaning it is impossible to roll a number greater than 15 on a single 6-sided die. So let's take a look at example 3 here. It says a fair coin, one of which is equally likely that heads or tails will result from a single toss, that's what it means to be fair, is tossed 3 times. What is the probability that 2 heads and 1 tail are tossed? Okay, so here's where I started by using the tree, and I said it was heads, tails, then each one of those breaks into heads and tails, and then each one of those breaks into heads and tails, and that's going to give me my total possibilities. It looks like I have heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Those were my 8 total possibilities for flipping a coin 3 times. So it says, what is the probability that you have 2 heads and 1 tails? Well, let's look at these and see which one of these options has 2 heads and 1 tails. Looks like heads, heads, tails has 2 heads and 1 tail. Heads, tails, heads has 2 heads and 1 tail. Also, tails, heads, heads has 2 heads and 1 tail. So when I look at this, what's the probability of getting 2 heads and 1 tail? Seems to me that it is 3 of the 8 total possible, which is a simplified fraction. So the probability of rolling 2 heads and 1 tail is 3/8. I want you to notice in this problem that we are not forcing the order when you read it. When it says 2 heads and 1 tail, that does not mean it's just heads, heads, tails. It means there's 2 heads total and 1 tail total. So be careful with that. Otherwise, the answer would be 1/8. So make sure you interpret that problem correctly. If a fair die is rolled once, what is the probability that an odd number will show on an upward face? Okay, so what are the odd faces? Well, the odd faces are 1, 3, and 5. Then think about the total number of faces. Well, that would be 1 through 6. So, what's the probability that it's odd? Well, it's the number of ways to get what you want. There's 3 odd numbers over the total number of ways. There's 6 total. Simplifying that, the probability of getting an odd number by rolling a fair die once is 1/2. Let's look at example 5. It says 2 fair dice are tossed. What is the probability that the sums of the pips of the face of the 2 dice equal 8? Let's remind ourselves what the total possibles look like. You've seen this chart many times already. We saw it in the previous section for sure. So what I would do is I would put this once on my note card or my cheat sheet, and then I'd just go ahead and copy this down onto that cheat sheet so it makes it a lot easier to you and you don't have to redo it every single time. But the idea is now I want to add the 2 numbers together. So a 1 and a 1 is a 2. A 1 and a 2 is a 3. And so on, and I'm going to add this through the entire chart. Go ahead and fill in that chart now, then verify against mine. So there's my chart completed. Now it says, what is the probability that the sums of the pips on the upward faces of the 2 dice equal 8? So let's look in here and see how many 8s do I have. I have 1, 2, 3, 4, 5 8s it seems. and there's a total of 6 times 6, which is 36 entries. So the probability of getting an 8 would be 5 of the 36 total possible. We want to make sure that we simplify that, and 536 is indeed simplified. Let's continue on. It says 2 fair dice are tossed. What is the probability that the sums of the pips of the upward faces of the 2 dice equals 7? So all I'm going to do is go back to the previous chart. I'm going to look at how many 7s are there. It seems to me that 6 of the sides are 7. So the probability of getting a 7 would be 6 of the 36 sides. Again, there's 6 7s out of the 36 entries, which simplifies to 1/6. So the probability of rolling a 7 is 1/6. Again, what we have been dealing with is theoretical probability. What should happen? To do theoretical probability, you always do what you want over the total possible. Now we're moving on to empirical probability. Again, when I think of empirical probability, I think of an experiment. I don't think of what should happen, I think what did happen. So the difference between theoretical probability of an event is always what you want over the total. Well, that's the exact same thing as experimental probability, but it's not what should occur, it's what did occur. So how many times did you get what you wanted, and how many total times did you do the experiment? So while it's the same formula, what you want over total possible, the only difference is not what should happen, it's what did happen.